Hey guys, it's me, Leah Applegarth. Today we're going to be talking about using linear models, which is 2-5. Our goal is to write linear equations that model real-world data and to make predictions from those linear models. Our essential understanding, you don't have to write this down, is that sometimes it's possible to model data from a real-world situation with a linear equation. You can then use the equation to draw conclusions about the situation. We're going to be using and looking at scatter plots, so write this definition down. Pause the video if you need to. A scatter plot is a graph that relates two sets of data by plotting the data as ordered pairs. So once you get your scatter plot plotted, you look for a correlation. So please write down correlation. A correlation indicates the strength of a relationship between two data sets. And I want you to draw a sketch of these graphs as they come up. So this is a weak negative correlation. So you can see the data values have a down into the left motion, but they're not tight together. That's called a weak negative correlation. If you just have data scattered all over your graph, there is no correlation. If your data is kind of separate, but it goes generally up as you go to the right, it's a weak positive correlation. And if your data is tighter together, like this data right here, then that's a strong positive correlation. You can have a strong negative correlation too. If these data values were tighter, closer together, like this data right here, then you could say it was a strong negative correlation. Okay, so take a second, pause this video, and write these different types of correlations down. Oh, here it is. Here's this. I forgot to click it. Here's the strong negative correlation. All right, we are going to use these this data here, number of hours online, and the test score to answer the question, making a scatter plot and describing the correlation. So the first thing I'm going to do is go to all we have to do is look at our data. I'm going to number on my graph here, on my x-axis, I go from 0 to 5, and I'm counting in increments of, I'm going to count in increments of 0.25. So on my x-axis, we start at 0, and it's going to be 0.25, 0.5, 0.75, and 1, and then 2, and then 3, 4, and 5. And then if you look at our data here, my test scores go from 60 to 100. I think it's important to have our graph start at 0. So this is hours online. Make sure you guys are putting this graph on your paper too. And this is your test score. So in this case, I'm going to count in increments of 5, just so that I'm not writing 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay, so now we plot these data. I'll plot my data in red. So I have one at 0, 100. I have one at 0, 94. I have one at 198. I have one at 188. I have one at 1.592. I have one at 1.75 and 89. I have one at 2 and 75. I have one at 2 and 70. One at 3 and 78. One at 4 and 72. One at 4.5, 57. So please make sure you guys are plotting along. And one at 560. All right, so we made the scatter plot, check. How would you describe the correlation? These numbers are, well, they're kind of tight together. Let's compare it to the picture up here. So we are definitely negative, but now we have to decide, are we strong negative or weak negative? And I would say it's a pretty strong negative. Our values are pretty tight together, so I'm comfortable saying a strong negative. All right. Next. The table shows the median home prices in California. What is an equation for a trend line that models the relationship between time and home prices? So this is how to make a trend line. So go ahead right here, either in your margin or somewhere mega important, put trend line, because these are the 3 steps to making a trend line. Okay, so the first thing we're going to do is make a scatter plot. 0 is going to be 1940. So go ahead and pause the video and make your scatter plot. All right, so if you put the median prices on the Y, and I counted by 10, I did it my median price in thousands, so this is 50,000, 100,000, 150, and I counted by increments of 10,000, and then I put my year. So 0 is 1940, 10 is 1950, 20 is 1960, so we increased by there. So if my data was following more tightly to this line here, I would have a strong positive correlation, but it kind of veers off. So I would say that this is a weak positive correlation. So step number 2 is sketch a trend line. Make sure it's a line, so make sure you use a ruler. And then let's choose 2 points on the trend line, and I'm going to choose, let's choose this point here and this coordinate here, and we are going to use those 2 points to write the equation of the line. We spent all last chapter practicing that, so let's do that. So the slope, not last chapter, but the last section. So the slope is y2 minus y1 over x2 minus x1. And this coordinate here is at 0, 36,700. And then this coordinate right here is at my 40, so 10, 20, 30, 40. It's 40, 167, 300. So we're going to find the slope of our line. So he is y2, 16,730 minus y1, 36,700, divided by x2 minus x1. So that is, our slope is 30,600 divided by 40. And then let's simplify that down. And that is 3,265. So if we use our slope-intercept equation, because my intercept is right here, this would be y equals 3,265x plus, and my intercept is at 36,700. So you find the equation, you find the slope, and then find the intercept and write your equation. Okay, so we're going to write these definitions down. The trend line that gives the most accurate model related data is the line of best fit. The correlation coefficient, or R, indicates the strength of the correlation. The closer R is to 1 or -1, the more closely the data resembles a line and the more accurate your model is likely to be. So let me show you how to do that on using a utility. So I Googled linear regression. So a linear regression calculator. So if you want, you can take this URL or you can just type linear regression calculator. You have to enter your X and Y values. So I'm just taking the values from our table. 20, 74, 400, 30, 88,700, 40, 167, and this program will actually calculate the line of best fit for you. 249, 800, and 60 at 211,500. We're going to submit the data, and it's going to make our graph. And then it gives us a equation of a line. So here's our slope. We calculated the slope to be 32,065. Their slope is 3575, which is pretty close. Their intercept was 19,353. And I'm looking for the R correlation coefficient. So click on correlation coefficient. Submit the data. And the correlation coefficient is right here. It's 0.93427. So let's copy that. So if we're following, the closer R is to 1 or -1, the more closely the data resembles a line, the more accurate our model is likely to be. We are at 0.93, so that's a pretty accurate, pretty close to 1. Okay, so we are going to use this data here to make a scatter plot and then use it to figure out how much we can pay for a gallon of milk in 2025. So I am going to input this data into our, we're going to let 1998 equal 0. So it's going to go 0. You guys can do this along with me, 2.57. 2000 is 2 years later, 2.83. 2002 is 4 years later, 2.93. 2004, 6 years later, 3.10, and 8 is 3.71. We're going to submit the data. The correlation coefficient is 0.94. It's not bad. Let's look at the linear regression. So here is our scatter plot. So go ahead and copy this down. And our equation is y equals 2.518 plus 0.1275x. And we're going to use that. Let me copy it. We're going to use that to predict the cost of milk in 2025. So let me see if I can get that equation. So I'm going to substitute 2025, so let's do a little math on that. 1998 is 27 years away from 1998. So for my x value, I'm going to put in 27. So when I do that on my calculator, we get 2.518 plus 0.1275 times 27. And I get $5.96 as the cost of milk. And that is our lesson for today. Thank you guys.